Global warming is an extremely serious issue. Scientists consider this an existential threat. So it is very important that all of us understand this issue. So we can try to understand what is this warming, and where are we now at this stage. It is important to remember that warming and cooling are part of process of Earth system. Okay. Why is it a part of the Earth system? It is a part of Earth system because ever since the Earth was created or came into existence 4.54 billions of years ago, this has been subjected to variation in solar radiation. Solar radiation variation. Okay. What is the source of this variation? So, around the sun, Earth is revolving. This distance between the sun and the Earth changes, not simply yearly, but over thousands of years. And also the tilt around with which the Earth revolves around the sun, the tilt also varies. So this is not perfectly circular, it is elliptical and changing ellipse because of influences from other planets and the tilt. So from the beginning of the Earth, there is a variation in solar radiation, which results in differences in temperature. At certain times, the Earth has sheets, ice sheets, and at certain times, there are no ice sheets. Ice here, and no ice. So, the history of the Earth is subjected to ice ages. Ice ages. Solar radiation differences are explained by what are called Milankovitch cycles. History of Earth is divided into ice ages and greenhouse periods. During greenhouse periods, no glaciers. And ice age itself is divided into glacial and interglacial. We are currently in interglacial period, which is also called Holocene. And glacials and interglacials are not of equal duration. Earth would be in the glacial stage for around 70 to 90,000 years. And interglacial around 10,000 years. Glacial and interglacial put together, it will be 1 lakh years. So, in an ice age, 70 to 90% glacial and around 10% interglacial. This is how Earth has been spending, going by radiation differences. But of course, radiation differences is only one of the things that the Earth's system is affected by. There are many other things. So how has this been working for the past 4.5 lakhs years? This is how this explains how this has been working for the past 4.5 lakhs of years. Four and a half lakhs years. Today, we are in interglacial. And around more than 1 lakh years ago, it was again interglacial. Glacial, glacial, interglacial. Like this has been going on. Interglacial temperatures are touching at 40 F. Glacials are much lower. So from this cycle, we can, it would be reasonable to expect that we would have entered glacial stage if not for civilization. And it is the civilization that made a difference to Earth system not entering the glacier. Scientists ask whether and when we would enter, that system enters the glacial now. Because glacial and interglacial is operating within a particular temperature range. So if we are out of that particular temperature range, we may not get back to the glacial once again. Okay. This is the point explained in this paper, Will Stefan and others in 2018, titled Trajectories of the Earth Systems in Anthropocene. So what does this explain? It is like this. Glacial interglacial cycle, this has been completed in 1 lakh years. The last cycle is completed within this temperature range. This is temperature corresponding to temperature sea level. That system would have completed or entered glacial, but scientists find that Earth system moved out of this cyclical process and like this. So it is out of this. An important point that they are making is, if the system moves out of or above 2C Celsius, above 2C, that is this 2C compared to pre-industrial level, okay, industrial level, industrial civilization, year is taken as 1750. So if the system moves above 2C, then it can't get back to glacial cycle. Then what will it be? Then instead of getting back to the glacial, it can take this particular trajectory, which is called hothouse Earth. And once it reaches this hothouse Earth, it may stay there for millions of years. That is, the system has been within this glacial interglacial for lakhs of years. Now, system temperature was rising in such a way, it is simply checked out of this cycle, and it will create a new system, a new source of stability, but at a much higher temperature, which means at that higher temperature, the life that we know now will not exist. Sea level will rise, of course, but the life that we know will not exist when it enters this hothouse Earth. The same thing is explained in a different diagram. If the Earth system is in glacial interglacial cycle, it will be like this, glacial interglacial. See, as the diagram shows, during the glacial age, it will be there for a longer time. And then interglacial only for short duration, and then comes back to the glacial. This has been going on like this. That has been moving like this. This is the time period. In the beginning of the Holocene, which took place around 11,700 years ago, that was when it is in the Holocene period agriculture developed. Earth entered interglacial, So if not for agriculture and then industrial revolution, the earth would have been interglacial for some time and then went back to the glacial. But what happened was agriculture and industrial civilization pushed the earth. This is the position now. And if it proceeds in the same way, then it will go like this. It will cross planetary threshold and then enters a new source of stability, but at a very high temperature for millions of years. So what is important now is to drive back the Earth system towards this, so that this cycle will not be disturbed. So Earth to be stabilized. So what does this mean? This means that agriculture plus industrial revolution pushed the earth away from this glacial interglacial cycle, limit cycle. Now it is going to drive down towards very high temperature and stable earth for millions of years, and the life would simply perish. But of course, after many millions of years, new life would emerge there. So the scientists are asking, can we prevent this process, fall of the earth into the hothouse earth, and drive back this to this? Do we have control over this process? How much control do we have? Okay. So these are important questions. But before Holocene, what were the ages of the earth? Earth is divided into, earth time is divided into era, period, and epochs. This is called geological time scale, which classifies geological strata. Earth history is traced through the material in its strata. Okay. The Holocene period we discussed started $11,700 years ago. And we evolved during this, what is called Cenozoic era. All this comes under Cenozoic era. Cenozoic era. Cenozoic era, starting from 65.5 million years ago, which is called Paleocene epoch. Paleocene, Eocene, Oligocene, Miocene, Pleistocene, Holocene. Holocene is the latest. And we crossed normal Holocene temperature and we are likely to move towards previous era temperatures. For example, this A is a mid-Holocene. A is a mid-Holocene. So A is a mid-Holocene and B refers to Eemian. Eemian is last interglacial temperature. Last interglacial took place between 1.3 lakh years and 1.15 lakh years. So last interglacial period was high. The temperature was not seen in the last 1 lakh years. So we may reach this last interglacial and then mid-Pliocene and then mid-Miocene and then hothouse Earth. What is the importance of knowing that we may reach mid-Pliocene and mid-Miocene? Because if we know the temperature that we are going to reach and if that matched mid-Pliocene and mid-Miocene, that will help us to explain or find out sea levels also. Okay, so in summary, we can say that Earth moved out of the glaciation system and we have to see when it will enter the hothouse Earth and whether we can prevent it.